Hey guys, welcome to lesson 5.1, where we start discussing probability. So definitions and relationships. So we're going to look at three basic tools to help us think about probability. A six-sided die, a bag of marbles, and a deck of 52 playing cards. All right, so a six-sided die. Our first definition is a simple event, which is a unique possible outcome of a random circumstance. So for example, one roll of a die has six simple events. You can roll a 1, a 2, a 3, a 4, a 5, or a 6. A sample space is the list of all simple events. So here the sample space for what can happen when you roll a die once. You can have 6 simple events. And we're going to assume that each of them is equally likely, so it's not any sort of weighted or rigged die. Now, I can also have compound events, which is a combination of multiple simple events. So for example, I could have event A be rolling an even number, so a 2, a 4, or a 6, or I can have event B being rolling an odd number, so like a 1, 3, or 5. So we already said an event is a collection of simple events, and a compound event contains 2 or more simple events. So for example, rolling an even number would be a compound event. Rolling a number less than 3, which would be 1 or a 2, would be another compound event. A complement is everything that's not A. So for example, if my event is rolling an odd number, a complement would be an even number. So if A is rolling a 1 or 2, the complement of A, written as A with a little c up there, would be rolling a 3, 4, 5, or 6. If events are mutually exclusive, events that are mutually exclusive basically cannot happen at the same time. So mutually exclusive. So rolling a 1 and a 2 are mutually exclusive events because I cannot roll a 1 and a 2 at the same time. But just because they're mutually exclusive does not mean they're complementary. So 1 and 2 can't happen at the same time, but together they don't add up to the whole sample space. So every complementary event is mutually exclusive, but mutually exclusive pairs are only complementary when they cover the whole sample space together. All right, let's look at a few practice problems. List the simple events and roll a number greater than 4. So that would be a 5 or a 6. Is this a simple event or a compound event? Compound event, it's a collection of simple events. Write the complement of roll a 1 or a 2. So the complement of rolling a 1 or a 2 would be a 3, 4, 5, or 6. And the probability of rolling one of those would be 4 out of 6, or 2/3. Give 2 events for one roll that are mutually exclusive but not complementary. All right, so 2 events. Event A would be rolling a 1. Event B would be rolling a 3. So those are mutually exclusive but not complementary. They're not complementary because together they don't make up the whole sample space, but they are mutually exclusive because you can't roll a 1 and a 3 at the same time. Bag of marbles. We have a bag with 6 marbles, 3 blue, 2 green, and 1 red. So each, if you reach into the bag, it's a well shuffled bag, well mixed, and you pull out one of the marbles, the probability of pulling out any single marble would be 1/6. The probability of pulling out a blue marble would be 3 out of 6, or 1/2. A green one would be 2 out of 6, or 1/3, and a red one would be just 1/6. And altogether, the probability of all those 3 together would be 1. So if I wanted to know if event A would be getting a blue marble, the complement of A would be not a blue marble, so it would be green or red. So those would be complementary. Mutually exclusive would be blue or green, for example. You can't have, if you pull out one marble, it's not going to be blue and green, right? You can't have both of them at the same time. Conditional probability. The probability of B given A, and it's denoted like this. So now we're looking at a situation where I draw one marble and then I draw another marble. So for example, if I draw two draws, no replacement. So the probability of blue would be 3 out of 6 or 1/2. The probability that the second one is blue, so if I draw two marbles and the first one is blue, so now I'm holding a blue marble. So holding blue marble. So I can think about it. So now there's only 2 blue marbles left in the bag, and there's 5 marbles left in the bag. So the bag itself, as soon as I'm holding a blue marble, the remaining content of the bag is different. Now there's 5 marbles, and 2 of them are blue, 2 of them are green, 1 of them is red. So that's called dependence. If I know that I'm holding a blue marble, then the probability of drawing another blue marble is different than if I don't know anything else. Is drawing a green marble a simple or compound event? This would be compound because there are 2 green marbles in the bag. Find probability of not blue. So there's a couple ways to think about that. So the probability of blue is 3 out of 6. So the probability of not blue would be 1 minus 3 out of 6, which is just 1/2. The other way of thinking about that is the probability of not blue is the probability of green or red, which is 3 out of 6. So either way, you end up with 1/2. 2 marbles are drawn without replacement. Find the probability that the second is green if the first is green, and compare it to the probability of green. So the probability that the first is green is 2 out of 6, or 1/3. And if I know that the first one is green, the probability that the second is green, so probability of green given green would be, now there's 1 green marble left in the bag and 5 total marbles left in the bag, so 1/5. All right, deck of cards, suits never overlap. So there are 4 basic suits in a deck of cards: hearts, diamonds, spades, and clubs. And the suits are mutually exclusive, which means you can't have a heart of clubs. You either have a heart or a club. Heart and king can overlap. So for example, I can have a king of hearts. There's 13 hearts in the deck, there's 4 kings in the deck, and there's 1 unique king of hearts. So clubs and spades are mutually exclusive, but kings and hearts are not mutually exclusive. You have, as long as there's something that is the intersection of the two, then it's not mutually exclusive. Another way of thinking about mutually exclusive is, right, a Venn diagram that has no intersection. So mutually exclusive. But if I have a Venn diagram that does have an intersection, this would be not mutually exclusive. So the definition of independence we want to use is the probability of A and B is the probability of A times the probability of B. So for example, in a deck of cards. Let's say A is a heart. So probability of A, there's 13 hearts out of 52. So 1/4. The probability event B would be being a king. There's 4 kings out of 52 in the deck, so 1/13. And the probability of A and B, so the probability of being a king of hearts, there's only 1 out of 52. So if I multiply that, probability of A, 1/4, probability of B, 1/13 is 1/52nd. So because of that, those two events are independent. So if probability of A times probability of B is the probability of A and B, those two events are independent. Now, this passes the King of Hearts, passes the independence test. Now, 2 marbles with no replacement. So now I'm pulling out 2 marbles out of a bag, no replacement. Probability that both of them are blue. So I pulled the first one out. First one is blue. Probability that the second one is blue is 3/6 times 2/5, which is 1/5. But the probability of a blue marble and a blue marble, just as I pull marbles, if I pull a marble out, the probability that it's blue is 1/2 times 1/2, which is 1/4. So those two things are not the same. So kind of intuitively, I know that if I pull out a red marble and there's another, or a blue marble, it's going to change the makeup of the bag, and it's going to affect whatever I pull next. All right, so let's look at a couple questions here. One card is drawn from a deck of cards. Is draw a queen of spades a simple event or a compound event? Drawing a queen, so drawing a queen would be compound. And drawing a king of spades, so there's only one. So that's a simple event. So there's only one queen of spades, but there's 4 different queens. Use the multiplication definition to test whether spade and ace are independent for a single draw. Show all 3 probabilities. So probability of spade is 13 out of 52, which is 1/4. The probability of ace is, there's 4 aces out of 52, which is 1/13. Probability of ace of spades is, there's only one ace of spades out of 52 cards. So 1/4 times 1/13 is 1/52nd. So those two are independent events. 2 cards are drawn without replacement. Find the probability that the second is a heart if the first is a heart. All right, so the probability that the first one is a heart is 1 out of 4. 1 out of 4. Now the probability that the second is a heart if the first one's a heart. So if I'm holding one heart in my hand, there are only 12 hearts left out of 51 cards. So there's one fewer card, one fewer heart, which means there's 12 out of 51. Explain whether the draws are independent or dependent. If I know that I'm holding a heart, then whatever is drawn next is going to be a dependent event. So key term, simple events, a unique possible outcome of a random circumstance, sample space, the collection of all simple events. So the sample space for a deck of cards is there's 52 different things, right? Each of them being a specific card. A compound event, an event containing 2 or more simple events. So for example, drawing a heart would be a compound event. There's 13 different hearts in a deck. Complement, everything A doesn't contain. So if event A is a heart, the complement of that is drawing a spade or club or diamond. Mutually exclusive cannot happen at the same time. You cannot draw a king and a queen at the same time. So if you draw one card, it's either going to be a king or a queen. Conditional probability, the probability of event B if event A happened. Independent events, Probability of A and B is equal to probability of A times probability of B. So knowing the outcome of one doesn't change the probability of the second. Dependent events, knowing the outcome of one changes the probability of the second. So summary, we looked at the die, 6 different events. We talked about even and odd being complementary. Marbles, that's kind of a classic example of dependent events if I pull out multiple marbles out of a bag without mixing them up. Independence is defined by multiplication. A and B are independent exactly when probability of A and B is probability of A times probability of B. Overlap is not dependence. You can have a heart and a king overlap at one card, and yet they are independent. So that is lesson 5.1.